So I thought we'd go ahead and get started. I guess we like to start all of our meetings with a safety moment. So this safety moment is really for me because this platform is really small and I like to walk around. So it's a huge tripping hazard for me. So if you see me fall, you may help me out here, okay? All right, so go ahead and get started with the presentation today around enterprise asset management and asset performance management tools and how they work together to perform a sort of an enterprise reliability approach. So just 60 seconds on me. My first 10 years of my career was a manufacturing engineer, industrial engineer in a lot of plants. And then the second 10 years of my career, I went to the dark side and I ended up at SAP for about 10 years working with their enterprise asset management system in the utilities industry. And then after that, another 10 years with a company called Meridian, where we did a lot of focus on reliability for fixed and rotating equipment. And then I've been at Allied, directing and leading the sales organization for about the last 4 years. So all in all, about 37 years in maintenance, operations, and reliability. Okay, so just a quick fun announcement for us, if we will. Allied became an alliance partner of Hexagon APM this month. So what does that mean? It means that we're not out selling the software, but we certainly are working with Hexagon and their customers to do the implementations of APM. So big start for us, and appreciate the opportunity from Hexagon and all the partners there to join the family. Okay, so what I'd like to do around this is typically how we work with our customers is focus on solving problems. So what are those problems that we typically work with our customers on? Typically around how they can produce more. We try to tie to their business strategy on becoming a low-cost producer or improving their quality. Anything around the production we certainly focus on. The second, I would say, problem they're trying to focus on is reducing costs. So cost around maintenance, whether it's labor, material, overhead, outside contractor costs, we focus on those as well. And then the last couple there is understanding and helping them manage their operational risk or risk associated with running their assets. So the real question is, can we accomplish some of these goals through working with the enterprise asset management and asset performance management tools that we're going to talk about today? So that's what we're going to spend about the next 45 minutes on, and with that, we'll jump right into it. Okay, so just a quick agenda. Wanted to talk about the core pieces of enterprise asset management and the capabilities that they have at a foundational element and how they support those business goals we were just talking about. The next step is to talk about asset performance management, that tool, and how it supports those goals and initiatives and some of those foundational elements. Next, really how they work together, and once we had them working together, how does that establish a platform for reliability, and then what do we look at next? Okay, so with that, I had to call an audible. So I had here planned for everyone to bring out their phones, but I don't have this connected to my laptop. So what I'm just going to ask is if there's anyone that's brave enough in the audience to give me just a quick sentence on what their perspective is on an enterprise asset management tool. Anybody? Brave enough? One sentence? No takers? Okay, that's fine. I expected that. So without the anonymity. So from my perspective, what is an asset management or enterprise asset management tool? It really allows us to focus on the assets that we have in our plant, the relationship of those assets in a hierarchy, parent-child relationship. Once we've established those components in our hierarchy, then provides us the ability to plan, execute, schedule, complete work, and assign cost to those work orders, labor, material, overhead. Also allows us to plan resources for executing that work and gathering a lot of other information there around it. So for purposes of this presentation today, I know that EAM systems do a ton of other things like documentation, lockout, tagout, permitting, but I just want to keep it pretty tight, if you will, for today's discussion around that and APM. So next up, I'd sort of like to use this construct for the rest of our presentation and the life cycle of the asset. So if we look at the top in the blue, it's really around the designing of the plant, maybe using smart plant foundation tools to do the design work. But then after we do that design, around the green, acquisition and commissioning the plant, operating and maintaining the plant at the bottom in orange, and then the disposal or decommission of the plant as an ending point. So really going to focus today on those last three items, acquisition, operate and maintain, and disposal. But in order to do that, I created a construct on the outside of this diagram, which is really focusing on the work streams that we tend to look at from an allied reliability perspective around operations, maintenance, and reliability. And those are defining the asset risk strategy. What are the pieces and parts there? The next is, once we define that asset strategy, how do we execute it? Then what are the data components we look at gathering to understand the strategy, and then the analytics. After we gather all that data, what are some of the analytics we look at, and how do those help us? And then finally, using those analytics to guide and direct us on failure elimination and continuous improvement. So with that, let's dive into the first piece around enterprise asset management. I know there's a lot of EAM experts in the audience, so I won't spend too much time on this, but really just want to provide a foundation on the basics, if you will. So when we look at the define the asset strategy work stream, a couple of the key pieces that we're using in the EAM is obviously the hierarchy, as we just alluded to, the parent-child relationship and all those definitions. But then really, once we define the asset strategy, we're using the EAM tool to actually execute pieces of that strategy, right? So some of the PM tasks, depending on some of the applications you may have, condition monitoring. Some EAM systems support operator rounds or lubrication rounds. So depending on your EAM, we might look at executing some of the pieces of that strategy in the EAM tool as well. And then finally, on the asset strategy piece, we're really going to define what are those critical spares that we need to execute that strategy in the EAM. So hopefully that gets us started. So once we have that asset strategy in the EAM tool, I guess I'd like everyone to think about a few things going forward. Where did that strategy come from? You know, how do we determine what was critical in the plants, right? How do we know what we're going to perform preventive maintenance on or condition monitoring on? So if you guys will just think about that for just a few minutes, we'll dive into that here shortly. Okay, so moving on to the next work stream, executing that asset strategy. From my perspective, this is where the EAMs perform a lot of the heavy lifting in this, right? This is what they were built for, to do the identification, the planning, the scheduling, executing of that asset strategy in regards to PMs, corrective work, depending again on operator rounds and other things. We're going to use the EAM for the storage and issue of materials, receipt of materials, and managing all that in the EAM, but the main core is focused around executing that asset strategy. So yeah, with that on the execution piece, let me move on here to the next as far as data collection. So there's a lot of applications out there we all work with, historians and APM solutions and production systems, but for purposes of this presentation, I'd like to focus from an EAM perspective on the work execution side. We're really gathering cost data, right? We're gathering labor, material, overhead when we go out and execute that work from a PM perspective or a corrective work. But there's a few other pieces of data that we're gathering as well, right? On a PM, we're gathering the as found, as left condition, so we can understand that. And then as well as when we do corrective work, we're gathering problem cause codes, remedy codes, when we're actually doing the work, so we can mine that data later in the process. So really a lot of critical information. And then the last piece here is just around integrating with accounting systems. Because we are gathering all this cost information, we're obviously going to shed it to the accounting systems for the value of our assets and how we depreciate them and all the other pieces and parts. Okay, so once we gather that data, then what do we do with it from an EAM perspective? this is really focusing on the maintenance side, right? So is our maintenance program working? So focus on those key metrics. So when we look at that, we're looking at first, are we compliant? So are we compliant with the preventive maintenance tasks that we've defined out of those strategies? Are we executing those on the right frequencies that we've identified? Then also, we want to look at the effectiveness of our maintenance. So are we finding failures? Are we having to do rework? Very often, based on our maintenance crew go out and doing the work, we start the equipment back up again, and within a day we have to shut it back down and go out and do rework. So we absolutely want to capture that. And then sort of a couple other pieces here is around the efficiency of the maintenance side. So really want to look at our planned estimates of time and material versus the actual of what's actually being used, because that tells us how efficient we are from the execution of the maintenance piece. And then the last area is around bad actors. And so that's not like Steven Seagal or Tim Allen or Kim Kardashian. It's really around looking at where are our costs incurred on the main assets, right? So we can look at where are all our costs going and how can we use that for continuous improvement in improving the maintenance side of our operations. So that's a little bit on the analytics. By no means is that all-encompassing, but just to, again, provide some of the foundation pieces. And then last sort of step in this work stream is continuous improvement. From my perspective, this is where I think the EAM systems are a little thin, if you will. I've seen a lot of companies use work request or notification types, depending on your EAM system, to identify improvement opportunities. So we're tracking, well, maybe we need to do a root cause analysis, or maybe we need to do some operator training or equipment redesign. So we can use and sort of configure some of those pieces to support those corrective actions or recommendations, if you will, and then track them through the system. But it's a little, I would say, superficial. And then what I've seen a lot is some ad hoc or bespoke tools that have been created in different EAM systems to allow us to do some of the typical studies we would from a reliability perspective or operations perspective. So hopefully that makes sense. What I wanted to do here was just bring all these pieces together. And so at Allied, we have a model, which is a maintenance and reliability systems model, that captures a lot of these pieces and parts and elements and how they work together to support a full maintenance and reliability program. So in this construct, we actually use this to work with our customers in each one of these elements and understand their maturity levels, their gaps, their issues, put together really an improvement plan based on all these findings, a little bit of a business case for the value, and then work with them to execute on this to build out this maintenance and reliability program for a value perspective, and we'll talk about that in a few minutes here. So hopefully that makes sense from an EAM perspective. Next, going to do a little bit of shifting and jiving here, but the question was, in your own words, what is an asset performance management system tool? So I'll pick that up and run with it based on where we're at. So, excuse me, do this. Okay, from my perspective, an asset performance management tool is for just a handful of things really, but they're very intricate. The first is we can use that tool to go out and do some determining of what assets are critical, right? There are specific tools in an APM system that allow us to do criticality analysis studies depending on what you're doing. And then once we define that criticality of those systems, we're going to work on the asset strategy and then execute components or pieces of that asset strategy in the asset performance management tool, and then look at how well is that strategy working. And then last but not least, what can we do to improve that strategy and make it more dialed in? So that's my sort of definition or construct of an asset performance management tool. And with that, let me jump in, and we'll use the same model just to discuss some of these major work streams and what are the pieces and parts of an asset performance management system that come into play in these work streams. So if we start out in defining the asset risk strategy, this is where I asked you guys to think about where that strategy comes from, right? So first and foremost, we have tools in the APM system that allow us to do walkdowns, plant walkdowns. So we're gathering the equipment data, nameplate data, attribute data. I'm sure that some of the EAM systems can do that as well. I just wanted to sort of define that and put it in its place for discussion purposes today. But once we have all those assets defined in our EAM system, so we're going to replicate that into our asset performance management system from a hierarchy perspective. And the next item we're doing is the criticality analysis. So there are a lot of tools in APM, as I referred to earlier, and methods to coming up with what are the assets that are most critical to us in our plants. And then once we have that defined, what are those more critical assets, we want to develop these asset strategies. So we can develop asset strategies a lot of different ways. There's failure modes effects analysis, there's RCM studies, but what I've seen with those, they typically require a lot of resources, right? We're going to pull people from maintenance, reliability, operations, safety, OEM in some cases for all those resources to get together in a room and define the failure modes and the mitigating tasks. And if you want to do that, that's absolutely a very highly engineered approach and successful for sure. But there are other approaches I would suggest you to think about and recommend. With the Hexagon APM solution, it comes with some components of an asset strategy library. And from an Allied perspective, we've been building our asset strategy library for about 25 to 30 years. So we've got about 3 million components in our library with failure modes, all the mitigating tasks, and based on that, the cause codes, problem codes, remedy codes with that. And then last but not least, depending on the mitigating task and some of the condition monitoring pieces, we actually provide upper and lower control limits for maybe vibration analysis or ultrasonics, depending on what you're using, because we've defined that failure mode and put in a condition monitoring piece, and we know what is right, what's normal, and what's not. Okay, just a couple other things I want to point out around the strategy pieces. Depending on what industry vertical you're in, you need to make sure you comply with regulatory compliance, right? So we've got a couple ideas up there for regulations on the electrical side with NFPA and their arc flash requirements. If you're in, excuse me, oil and gas environment, American Petroleum Institute standards for fixed equipment, boiler type specifications. And then there might be some mandatory tasks in food and beverage. If you're making food every, I think it's 24, 48 hours, you have to do a sanitary washdown. So the point is, when we're developing these asset strategies, we want to consider all the pieces and parts. The OEMs have requirements that you need to include their tasks so you don't void the warranty on the equipment. So all those pieces and parts coming into defining the asset strategy and the pieces and parts, and that's why I think we're doing a lot of the heavy lifting in this area in the asset performance management tool. Okay, hopefully that makes sense. Moving on into executing the strategy, this is where I would say the asset performance management tool is a little thin. And all I mean by that is based on the asset strategies and the failure modes and mitigating tasks, we're going to come up with the cause code, failure code, reason codes that we can actually put back in the enterprise asset management tool. So when you're executing the work, you can store those cause codes for us to analyze from a maintenance and reliability perspective on a quarterly, yearly basis and understand opportunities for improvement. One other piece really around the execution is some of the real-time data. We do that in the asset performance management tool in terms of tying into a historian and tracking temperature, pressure differentials, amperage, voltages, depending on the failure modes of the asset. So we can identify what's normal there and what's out of range, if you will. And when those happen, identify what we need to do. So hopefully that sort of ties off the execution of the strategy piece. From an asset performance management perspective. And then as far as data collection goes, from my perspective in an asset performance management tool, we want it all, right? So we're trying to gather any and all we can. I see at the top of the screen we've got production and production loss data, but we're not trying to turn the APM system into another production system. We're just trying to get, the high level, what's the production been for that line, for that plant, for that system, and then what are the main production losses, because we're going to use that in just a minute in the analysis pieces. Talked about historian data. We absolutely want to connect to the historian and get the real-time data. Tying into the work order history, absolutely want the preventive maintenance as found, as left data so we can look at intervals and make sure we can optimize some of the intervals on the PMs that we're executing. On the corrective work, the findings, the failure codes, the costs as well. And then depending on the EM and what you're using it for, operator care. So we want to know what they're finding out in the field as far as tank levels, any issues that they're seeing from visual, from touch, from smell, and then depending on lubrication results. How much lubrication are we using? Did we see or find any leaks, any issues with some of the lubrication equipment, oil mist systems, anything like that? We want to bring that back into the APM system for analysis. Okay, so with that, let's talk real quick about the analytics side. So in the maintenance system or EAM, we're focused on maintenance program. In the asset performance management system, we're focused on the strategy. Is our strategy working? So how do we define that? And so what are some of the metrics that we typically use? So we're starting to bring in some of the reliability metrics of mean time between failure, mean time to repair that are calculated. And then we're using the failure codes and failure modes, which are not covered. We may have some failure modes that we've identified from an asset strategy perspective that, hey, we're still having failures on this equipment, but we don't have that specific failure mode covered with the mitigating tasks. So we want to make sure we address that. We talked about the PM as found, as left data. We certainly want to use that for understanding the frequency of the PMs. If we're doing it every month, and we're not finding any issues, why would we keep doing that every month? So we want to look at moving out those intervals or maybe bringing in intervals where we're not finding any issues, but we need to. So I talked about bad actors earlier, but from my perspective, we want to look at bad actors from a failure perspective, cost perspective, and then also from a production loss perspective. So we can lay those over each other and see if they provide us some consistencies. And if they don't, that's fine, obviously, right? We can still chase those different bad actors, but at least we know where we're at from a production impact and from a cost impact. And sometimes those overlay depending on what industry you're in. And last but not least, asset health. So we can use a lot of this data, pieces and parts of it, to do asset health calculation, which is a little bit more complex depending on what you're trying to accomplish. And then finally, we can take that asset health calculation with a criticality index and do some math magic and come up with operational risk, if you will. So that operational asset risk can help us with capital planning and expenditures and prioritizing where we want to spend those dollars based on asset risk. Okay, and then last but not least, we want to talk about failure elimination. From my perspective, this is where the asset performance management systems provide a lot of gold. So what do I mean by that? I mean that we have a lot of tools in the APM system, typically for identifying and executing some of these improvement efforts. The first one is really around root cause analysis, right? So we have a bad actor problem we've identified. We need to go do a root cause analysis so we can actually perform that study in the asset performance management tool, identify the corrective actions or the advisories, corrective actions or advisories that we need to put forth and execute on those. And we can actually track those corrective actions and advisories very well in a fit-for-purpose tool in asset performance management. So we can assign those, we can track them all the way through to impact for production and risk. And then the last piece here, I do have artificial intelligence tools. There's some of these that can help us identify potential failures even earlier, depending on what we're doing and how we're tracking the right data into the AI tool. So that sort of wraps up the asset performance management piece. of those elements. And with that, I wanted to just bring those elements into this construct of a whole maintenance and reliability program. And I think you can start to see how these two applications rely on one another for different pieces and parts. But you can see here that there's still a couple of components missing. So wanted to talk about that real quick and why it's important. So quick question for the audience is why do projects fail, right? So there's a million reasons why projects fail, right? I just wanted to get you guys thinking about in your head what comes to mind from your perspective. But from an Allied perspective, we've dealt with this for about 25 years. And why do projects fail really comes down to a lack of governance and change management, right? The EAM/APM tools, they don't go in overnight. They take typically several months to implement. And when we do that, we're changing processes, right? We're changing how people do things. We're changing their roles and responsibilities. Because this happens in months and not days, we start running into competing initiatives within organizations, so we have to deal with and manage those competing initiatives. And then finally, we're asking people to think about things differently and tracking new KPIs. So just wanted to bring that into play about how we need to make sure we're managing the change in this overall construct of asset performance management and enterprise asset management. So just wanted to briefly provide some things for you guys to think about. At Allied, we have an approach to address this, and we have termed it the parallel organization. So just 3 quick items on the parallel organization. What you notice in this slide, we're looking at three levels of the organization. We're looking at the executive or corporate side with the executive sponsor, executive team. Below that, at the plant level, we have the plant manager and his leadership team, maybe a change management person there at the plant level. And then at the third level is really at the execution of the work streams. For asset reliability, MRO items, work execution, we have people that are assigned as leaders for those improvement teams and work streams that we want to include in the organization. So that's the first piece that's important about the parallel organization. The second piece is the team charter there in the upper left. So what is the team charter doing? It's really defining what are we trying to accomplish here? What's the time frame we're looking at? What are the goals and objectives, the people, what's our communication plan? How is all this going to impact and sort out with different initiatives that are going to come into the business? So once we define that team charter, the third piece that's really important is the feedback mechanisms that we have in play. So the feedback mechanisms from the team leads out at the shop floor level up to the plant manager. What's going on? What are the issues? What are the roadblocks? How are we progressing? How do we work together? What things are going well? That feedback is then made back up to the executive steering committee and sponsors for help in addressing these issues and making sure that we're actually making progress. So just a couple quick points I wanted to make on the change management piece. And so when we bring those items into the construct of the maintenance and reliability systems, you can see that we built it out, right? So this is how the APM systems and enterprise asset management systems work together. So after going through all that detail, let's take a step back. Take a breath, because I know that was a lot of detail, but really I wanted to talk about the starting point. The starting point is the enterprise asset management system, right? We're using that hierarchy and construct, but we're leveraging that into the asset performance management system to leverage that piece. When we get that into the asset performance management system, we're developing the strategies, and in some cases we're executing pieces of that strategy, but we're pushing components of that to the EAM for execution. We execute the work and the PMs in the enterprise asset management system, collect the data, bring all that over into the asset performance management system for data analysis and opportunities for improvement, and we continue that cycle on and on. So hopefully that makes sense, but let's take a time out, because I just hear someone in the audience with a question that says, but Gary, there are hundreds are thousands of companies out there that have an enterprise asset management system, but they don't have an asset performance management system. And they're working and they're selling their products and they're making money to some degree. So what? What's the big deal? Why do you need this APM system? So just want to throw this out here for some discussion purposes and maybe spike some ideas, but we've done studies around this and experiments. If you look at the left side of the graph, that represents companies that really don't have a lot of PMs in place. And I say PMs, preventive maintenance tasks, condition monitoring tasks, operating tasks, the tasks go on. They just don't have a lot of them. So what are they doing? They're incurring a lot of failures, a lot of cost of repairs, a lot of production losses. So the cost is high, the production is low, right? But then if we go to the far right of the diagram here, we have companies, they're doing a lot of PMs, they're doing a lot of condition monitoring, a lot of operator rounds, a lot of. Well, hold on, they're still having some failures. Their cost of repair has reduced, but they still have production losses. Why is that? Because they're not addressing the right failure modes, right? They could still be doing a lot of PMs, but they're not addressing the right issues, so they're still doing the wrong thing over and over and over again. So their costs are incurred, they're still having some failures, and they're losing production. So that brings us back to the middle of the graph here and why it's important to have an asset performance management system working with an enterprise asset management system. Once we dial in that strategy and execute it based on the failure modes and tying it in with the EAM, we can perform the right level of preventive maintenance tasks, condition monitoring tasks, address the cost of repairs, dial in the right production with minimized production losses, and optimize our production, our costs, and our risk. So that's what this is all about, right? And again, how these two systems tie together. Okay, so let's do this. We're sort of rounding third and heading for home, if you will. But now that we have all of these pieces and parts in play and we're starting to execute them all, now what? Excuse me, now what do we do? Well, what we found is many companies are doing a lot of these pieces and parts, but they really want to become a proactive organization. They're still in a reactive mode, right, in doing these things, but we want to be more of a proactive organization and get more value. So wanted to talk briefly about adding in a condition monitoring program, a complete condition monitoring program. So if you look at this, what does a condition monitoring program actually do? Is anybody familiar with this diagram, audience? Yeah? Seen it before? Yes, sir? Okay, this is a P to F curve. Potential failure is identified up at the top left, and full functional failure occurs here, and we have a breakdown. We have to go fix the equipment, is really what it's representing. So what we're trying to do here is move back up this curve, and what does that get us? It buys us time. And so it's buying us time to plan, schedule, and execute the work when we want to on that equipment. Because if we don't do that, the equipment's going to tell us when we're going to do the work, right? It's going to break on New Year's Eve or Christmas Eve at 3 o'clock in the morning, and you got to bring someone in on overtime, and you got to expedite parts, and the list goes on. So it becomes very costly. But there are different ways to get us back up this curve, right? We do operator rounds where we have people using senses like feel, touch, smell, hearing, all of those pieces and parts, which get us up a little bit up the curve. But there's a whole list of condition monitoring tools that allow us to get way up the curve, and those are vibration analysis, infrared analysis, ultrasonic analysis, motor current analysis, and the list goes on. So those are the things that are really going to help us get up that curve, buy us time, and even help us be more proactive and manage our cost and production even more. So I just wanted to highlight a few things around that. You know, there are a lot of tools out there. Allied, we have a tool in we call it Smart CBM, that provides a condition monitoring platform. And a few key things I would urge you to consider or look at is, you know, a platform that can bring all these different technologies into one place. right, for vibration, IR, UE, because if you don't, you're going to have your analysts using 5 or 6 different systems trying to correlate all this data and figure out what we need to do. So that's number one. Number two is we have a lot of experts that are certified level 1, 2, 3 for vibration, IR, and UE as far as their analysis capabilities and looking at that data, understanding very specifically what that vibration analysis is telling them. Is it an inboard bearing or an outboard bearing? Is it a shaft alignment problem? So we can zero in on specific issues quickly. And then the last piece is integrating this into the enterprise asset management system and also the asset performance management system. So all of these systems can play together and leverage each other. So just on to the next piece, we've talked about the enterprise asset management system and the work order data that it uses, and the asset performance management system around the strategy pieces and data that it uses. These are just some examples of, condition monitoring pieces of data that we use day in and day out. At the top left, I know it's hard to read, but it's an example oil analysis, right? That's going to tell you whether you've got viscosity problems, contaminant problems, water solution problems. Then at the top right and bottom left are example vibration waveform analysis pieces that we can look at and understand. And at the bottom right is an example of an infrared shot, right? We're looking at hot spots on the pieces of equipment or electrical panels on where we need to address those issues based on an infrared analysis. Okay, just a couple closing items here is just like the enterprise asset management system, asset performance management system, there's a dashboard for condition monitoring in that program, right? How compliant are we on the condition monitoring tasks? Do we have any faults that we've identified that aren't being addressed? What's the mean time to implement and fix those problems that we identify? Also some bad actors by condition monitoring. If we haven't talked about that enough, there's some analysis around bad actors from a condition monitoring program as well. So just a few items here. So how do these systems work together and why do we need them? Just to provide a couple of last points. The EAM is really the system of record for the assets, right? We've talked about that, the hierarchy, the parent-child relationship, and the construct there. So we're actually leveraging that enterprise asset management hierarchy into the asset performance strategy piece, and then also into the condition monitoring. So why is that? We're doing that because when we create the strategy, it links to the same pieces and parts in the EAM. If we find problems from a condition perspective and we have to do corrective work on that and we identify problems, we can notify the EAM with the same part numbers, same asset numbers that are in the construct there. So it's really a key piece that ties all of them together. If you look at it from an asset performance management perspective, we're leveraging the strategy there, both in the EAM tool for PM execution, in the APM tool for the real time, and then also in the condition monitoring for those condition monitoring details, right? And then last but not least, when we look at the condition monitoring tool, when we find problems with assets there, we're going to create a work request back into the EAM and let them know there's a problem that need to be fixed. And then as well, we may find issues with equipment that may not be ready for a work request, but we still want the asset performance management tool to know about them, right? Because we may have issues with the strategy. So we're going to send a lot of our findings as advisories back into the asset performance management tool to link all of this together. Okay, so last couple items is really just wanted to provide a case study or a success story, if you will. This one specifically is in the food and beverage industry. You can see across the top the major, I would say, improvements that were made. We had about a 28% reduction in annual maintenance spend. We had about a 9% increase in OEE. Now that was over 4 years, all right, so it wasn't immediate because it took time to get these processes and things in place and the change management like we talked about. But 9% in OEE and then about a 30% reduction in inventory. And that happened because we were doing the right strategies at the right place and not having to keep all this inventory on hand just in case, right? So how did we do this? How did we get to these benefits? It was doing pretty much what we've talked about the last 45 minutes. First thing first is we made sure we had the right assets identified and validated them, performed a criticality analysis, made sure we understood what assets were important and consistent across the organization. And then we designed the asset strategies based on failure modes and implemented those. Did a lot of work around the work execution side with the asset management or enterprise asset management tool and the people executing that work stream. And then we put in a condition-based monitoring program, right, and all of this together. So all those pieces and parts together allowed us to bring that value to the customer. And there's additional ones that we have for sure. And then I know we're running short on time. I was just going to ask in general if the audience has a condition monitoring program or not, and if you've had it for a while. So you never know. Some people are just figuring it out. So, okay, so let me do this in closing. So what are the key takeaways I would like everyone to walk away with? First is improving production, cost, and risk. It's not easy. I mean, that's why we're all here, right? If it were easy, it'd already be done. So it's a complex thing that we have to go in and figure out. I believe that these solutions from an enterprise asset management, asset performance management, condition monitoring, using these tools can certainly help us solve these problems and address these functional silo issues. In some cases, you might need a reliability assessment or roadmap to help drive the organization in the right direction with priority and a business case and KPIs to drive it. And then finally, through the example business case, I believe tremendous value can be realized by organizations in getting these applications, processes, and things to work together. So hopefully that was interesting and helpful for everyone. So for me, that's the sort of end of my presentation, and I'll open it up for any questions that anybody might have. Yes, sir.
I know you're a relatively new partner, but the interfaces between the condition monitoring and APM and EAM, will they exist, or will they exist as APIs? Or?
Yeah, that's a great question. So actually, before we formed this alliance with Hexagon, we actually have an open interface tool that we already have on the condition monitoring tool. So we've interfaced it with Maximo, with SAP, and others already. But we have a great question because it's going to take us a little bit of time to, tie off the right hooks with Hexagon APM and their APM tool as well. So just to be fair, yeah, great question. Anybody else? Other questions? Was that clear? Okay. Well, thank you very much for your time. I appreciate it. Yeah.
I've heard a couple of things that differentiate the Hexagon APM tools from other tools on the market.
Yeah, from the Hexagon APM and other APMs. Wow, that's a good question. I'm not sure that I'm actually qualified to answer that because I haven't spent a lot of time in the Hexagon EAM tool. But yeah, I'll have to get back to you. I'm sorry.
Okay.
Yeah. But if there's another EAM person in here that might want to help out, I'm all ears. Yes, sir.
That's what I was going to talk to you about.
Okay. We have another taker, right? Okay. So I'm happy to do that as well. All right. Any other questions? Don't be shy. Okay. Well, thank you all for your time. I really appreciate it. Thank you.